Hi, Dave Soriano. This lecture is on next generation feedstocks, biomass residues, and organic wastes that can be considered for the production of biofuels. This installment is from a course I teach at the University of Pittsburgh Bradford in Bradford, Pennsylvania, USA, and the course is titled Introduction to Biofuels. Perhaps there's something here that can be of value to you. Biomass residues are diverse. A distinction can be made between primary, secondary, tertiary residues and waste. Waste, available as byproduct of other activities. Primary residues, generated during production of food crops and forest products. Straw, corn stalks, leaves, or wood thinning from commercial forestry. Such biomass streams are typically available in the field and must be collected to be available for additional use. Secondary residues, generated during the processing of biomass for production of food products or biomass materials. These include nutshells, sugarcane bagasse, and sawdust, and they are typically available at food beverage industry sites, saw and paper mills, etc. Tertiary residues become available after a biomass-derived commodity has been used. A diversity of waste streams is part of this category, such as organic fraction of municipal solid waste, demolition wood, sludges, etc. In general, biomass residues are intertwined with a complexity of markets. Many residues have useful applications as fodder, fertilizer, and soil conditioner, or as raw material for particle board production, medium density fiberboard, and recycled paper. Net availability and market prices of biomass residues waste depends on market demand, local and international markets for various raw materials, and the type of waste treatment technology deployed for the remaining material. The net availability of organic waste residues can fluctuate based on market conditions and weather, among other variables. The physical and chemical properties of this diverse spectrum of biomass resources also varies widely. Certain streams such as sewage sludge, manure from dairy and swine farms, and food processing residues are very wet with moisture contents over 60 to 70%, usually better as a biogas feedstock. Some waste streams may be contaminated with heavy metals or high sulfur nitrogen chloride levels, for example. Wood residues, forest residues. Over the last century, human efforts to control or limit forest fires have been quite successful. However, this can lead to an excessive amount of undergrowth, often small diameter trees, in forests, which can lead to forest health imbalances. Creating a market for this woody undergrowth for use in biomass to liquid fuels, BTL, may complement efforts to create healthier forests. Industrial and urban woody residues. Much of the wood residues produced by the lumber industry are used to provide the energy needed for the lumber production process, lumber drying, cogeneration of heat and power, though some of this wood may be available for biofuel uses. The paper mills tend to use much of the wood waste as boiler fuel. The black liquor residue requires expensive boilers for disposal, and this could be a potential source for biofuel production. Mostly hemicelluloses are present in the black liquor, which is a byproduct of paper making. Black liquor. There is an extensive amount of C5C6 sugars in this residue, hemicellulose material, and it can be used to make ethanol. The US DOE is working with paper mills to foster ethanol production from the black liquor residue. Wood from urban tree pruning has use in electric power production, mulch use, but some may be used to make fuel. Municipal solid waste. A mix of cellulosic waste material is typically present in municipal solid waste, including wood, paper, cardboard, and waste fabrics. Fees are generally charged to dispose of this waste and could be a supply of low-cost biomass for some pioneering cellulose to biofuels facilities in urban areas. Crop residues. Stems and leaves from food crop harvesting represents a substantial quantity of cellulosic biomass produced annually. Much of it must be left in the field to prevent erosion and to supply micronutrients, soil organic matter, and enhanced soil tilth. soil texture, structure, and pore spacing. The latter. Where land is flat or conservation tillage is practiced, a portion of crop residue may be harvested. Rapeseed, canola in North America, rapeseed in Europe, very closely related, soybean residues are not sufficient to warrant collection, in part because current varieties of these plants decompose too quickly. Better farm practices have or are being developed. No-till cultivation, where soil is left undisturbed from harvest to planting, with only a narrow drill hole used to plant seed. Weeds are controlled with herbicides. In the United States, 23%, this is from the year 2004, of our farms use these practices. No-till cultivation may allow 75% of corn stover, that's the stalks and leaves remaining after harvest. The corn stover can be harvested where soil erosion and land slope problems are not occurring. Next lecture, we will consider corn stover and wheat straw, and we will look at the United States Patent Database. Thank you for listening. Listen to our other lectures being uploaded to YouTube. Thank you much.